Hello, everybody, and welcome back to day 2. So this is going to be basically finishing up where we kind of left off last time, still covering a few different basics. That test reminder is not due for another 4 days or so, till the end of this week on Sunday. And we'll also be, for the second part of lecture, digging into the navigation system a bit. So to get started, we'll be doing some more of the basic stuff. We'll open up that same project that we had from last class. Let Unreal load. All right. So as you can see, this is just a blank level like when we first created the project. My actual level, I had renamed and actually saved a level here called UE4 Basics. That was one of the first things we did when we started the project. The level it chooses to load when you open the editor is actually in the project settings. So let's go set that so the next time we open this project, it just goes to the same level that we had. So we'll go to the project settings. And in here, there's a bunch of settings as mentioned before. We're going to project, maps, and modes here. And right here is where it defines what editor startup map it's going to use. It's using a basic template default. We want to go to the one that we created, UE4 Basics. Once you have that set, just close out of the settings, and let's even just reopen the project to see that that setting is working. Give Epic Games Launcher a moment to pop back up. Try and reopen that basics again. And boom, it now loaded into that level we were working in from last class. You can also just manually double click it. I just wanted to make sure that that project setting was working there. So we play to see where we left off. We had the projectiles shooting out of the cannons. We have a print happening every time it spawns one of those projectiles. And we have these pickups that can modify the player. All right. For the next topic that we're going to introduce is another form of communication. We already talked about direct communication as well as interface communication. Let's go ahead and see how we can add another form of communication with a pretty simple setup. Let's set up some sort of kind of like button that we walk up to, and basically when we touch it, it's going to activate the button, and then we'll have that send off another message and something else can respond to it, maybe a moving platform or something. So we have a couple of objects to create for this. First object we'll go with is going to be the kind of button, or let's go for a simple lever. So we'll create a blueprint class. It'll be of type actor. Give this a name. We'll call it BP underscore lever or switch. We'll call it switch. Open this up, and we gotta actually lay out how we want this switch to work. I'm gonna add a few different components to it. First thing I know I'm gonna need, I need to detect collision with my player. So when my player walks up to it, it switches this switch. So let's go ahead and add a sphere, but rather than just the sphere that we can see in the level, let's go for a full sphere collision. I want the to explicitly say where those collision volume is. With that, we'll bump up the scale. I'm going to lock these so it scales uniformly so that it's a little bit bigger than kind of where I'm going to put my button. Or I keep saying button, but I mean switch. Next up, let's add a just a box or cube. And give me 1 second, my Alexa's being annoying. All right, sorry about that. All right. 1 more second, let me actually pause. All right, now that that's taken care of, I added just a cube to represent the switch arm or whatever we want to call it. Let's go ahead and scale this up. Not move the camera into it. And we'll scale down, make it a little bit of a lever type thing. I want this to basically simulate rotating like a switch would when it's on versus when it's off. But I don't want it rotating right around the origin here. It's kind of weird having the whole lever go like that. So if we wanted to have it rotate around a certain axis or something, we could move that up to kind of put it at match the origin down here. And we'll add another component. And just like you've probably worked with empty game objects to have like a different pivot point or something, we can add just a simple scene node as a way to attach other objects to it. Now it just attached to cube because I had that selected already, but we'll go ahead and attach this to the root. And we'll attach our cube. Let's rename this from cube to lever or switch arm. The new scene node that we just placed, let's have this represent switch pivot. And now as we rotate this pivot around, if we switch to the rotate, we'll see that that switch will go to one side or another, etc. And I do notice that it is huge compared to my trigger volume. And we'll rename this from sphere to trigger volume. So we'll probably end up scaling that up a bit more as well. Now this might be huge when we place it in a level. We'll just scale it back down as needed. We'll say if our player gets within that bound, it'll flip the switch from normal to on or off. And let's throw in a couple more things to indicate which way is on, which way is off. Let's throw a text render component on there. And this will be off text. Move that to this side. Rename the actual text that it's got showing up to off. And we'll duplicate this so we can have on be on the other side. Of course, rename on text. Then we need to get something set up so that it can pivot. We have our pivot set, but we're going to need to animate this.
The text to be on too.
Oh, yes. Good call. Thank you for that. Always little things. So we have on that way, off this way. I'm going to rotate my switch pivot. Let's say -50 will be for off. That's what way it's going to start in. And then so +50, as we can see this, would be like 100 plus that. So let's get it back. Come on. Sorry, I was running out of mousepad space there. Switch pivot, compile. All right, so we have it in its off position initially. When our player walks into this, I want it to flip over to the on position. So we're going to set up an event stuff in the event graph. Our trigger volume itself is currently set up to overlap with everything. I don't necessarily want that. If one of the projectiles hits it, I'm going to say ignore those, but overlap only with a pawn. So our pawn will be able to generate these overlap events. So when an actor begins overlapping, we'll go ahead and toggle this switch pivot. So we're going to need to track what current state it's in, whether it is to represent a rotator. We'll have two rotators. First one will be our off rotation. Our second one will be our on rotation. If our game starts with this switch pivot rotated at exactly 50, we'll go ahead and be able to just set this off rotation to its current rotation. So we'll pull that variable in and just grab what the off version is, write it as soon as the game begins. So we have to ask specifically this component. If I just try and do like, and actually that's a good point to point that out. Depending on which component you have selected, let's say we have the trigger volume selected and I right click here. It's not only searching for actions that this blueprint can do, but it's also going to show things for that trigger volume component as well. So if we do have our switch pivot selected and search for get relative rotation, and we'll have to get the entire transform. It'll get it from that switch pivot. The transform itself actually has the location, rotation, and scale all built into it. So we'll split this struct apart since we only want the rotation value from it. All right, so our off rotation is set. I mentioned in the as we're in the viewport and playing with these different values, if we wanted to say rotate this, well, not rotate the switch arm, rotate the pivot. Rotate the pivot, the on would be minus 90 roll, or minus 100. That's rotating it around the x-axis here. So let's reset that back to -50. If we wanted to set our on rotation, we can actually split the rotation structure as well. So we'll say our X rotation or our roll rotation will be the one that we want to change. Our Y will just go straight in. Our Z will just go straight in. But for our roll, I'd basically want that in the viewport. If switch pivot is 50 right now, and my goal is to get it at -50 for the on, we can just multiply that by a negative. Let's reset this. So roll, let's say, is going to be a negative multiplied by a -1. All right. Now we just have these variables set. We haven't done any rotation or anything yet, and we haven't handled our begin overlap. There's a few things we can do with that. When we do detect our player overlapping, we can basically figure out what way this switch is oriented by asking our switch pivot for its rotation. Same thing we were doing up here at beginning of play. And specifically that X value is the only one changing, so we'll just be comparing that. We'll split that, just the roll. We'll say is nearly, and we can ask it for if it's nearly the same as a vector or things like that. I'm going to recombine this so it is a rotator. I think rotator has a is nearly as well. No. We will go the float route. We'll say, just compare that is equal to, oh, there is a nearly equal. It just doesn't have is in front of it. We'll say nearly equal. The reason why you generally want to avoid is equal to when you're dealing with floats is something called floating point error. There is a bit of error with floats. It is only precise to 8 decimal points. So by doing nearly equal, well, if it's really close, but not quite exactly equal, we'll figure that out. And we'll just be checking if the bool I want is to know if it is currently off. So we'll compare what it currently is to off. We'll split this apart, and our A comes from current, B comes from the off rotation value. And we'll branch. You can hold B and just click to get yourself a branch. So if this is off, that'll be this true value. If it is off, we want to set the rotation to be on. So we will need our on, and we will be rotating our pivot. So we could do it the old-fashioned way of dragging that in versus just selecting and searching straight from it. We'll look for set relative rotation. And we want that to run when that's true. Once again, we're setting that on, and we're targeting the switch pivot to be rotated. Same thing, except the opposite for off. Rather than telling it to set its rotation to on, we'll be setting its rotation to off. All right. So let's go and add this into our level. That is a big switch compared to our character size, but good enough. And we see it is judging from the text looking this way. So we'll rotate that around real quick. So we have the on the left, or off on the left, on the right. We play and we walk up to it, it turned it on. If we walk out of it and walk back into that trigger, it goes off. Cool. We have a pretty simple switch setup that just changes every time. Nope. See, there is a bit of a issue. It's currently stuck in the off position. This gives actually a great opportunity. While it is in this off position, I'm going to keep the game playing, grab my mouse back, on here, we can debug what's going on here. Yes, you could use a timeline and everything. I just wanted to try and keep it a little bit straightforward with just setting the rotation directly. But here we have the actor begin overlap. If we want to know what's happening during this time, we can actually add a breakpoint and see what's going on as it's rotating through here, or as it's running this code. So the game is still running. I have a breakpoint right here. If we run into this, it detected the overlap. There's a few different options to continue stepping the code. We'll say just step over to the next node here. We're getting to this condition where we're checking if the current pivot, and when we hover over these actual data pins, we'll be able to see that. 50.0 blah 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 65. Our off rotation itself is 50, pretty dang close, but not quite. That's why I have this nearly equal here though. I knew this was going to happen. We'll say we'll allow a bit more tolerance to not say for those floats. Let's go ahead and say if it's 100th of a degree off, we'll still consider it the same. So now with that, we'll remove our breakpoint so it doesn't pause the code again. Give this another play. Boom, and boom, and boom. All right. So it is working again, not just the once or twice that it was. All right. So we've got that switch working. Now we need to basically have this switch send out a message about what state it's in. So for that is the last communication method that we haven't covered yet, the dispatchers. What a dispatcher is, it basically is a way for an object to basically shout out into the world, hey, this thing happened, or send whatever data it wants. There's a few built-in dispatchers and stuff to actors. If we go ahead and show inherited stuff, our event dispatchers will be filled out, and there's collision dispatchers for when things hit it, game stuff for when it's receiving damage or when it's destroying, input dispatchers for mouse or touch, stuff like that. We're going to create our own dispatcher here. And I'm going to say the name of this dispatcher is the switch changed. Switch changed. With that, I want to send information along with this dispatcher. So with the dispatcher selected, we are able to pass inputs into it. I'm going to send in a bool for if it just turned on or if it just turned off, something like that. We'll call this just turned on question mark. All right. So we have this dispatcher set up, and right now we have no idea what we're going to send this to or what's going to respond to it, but that doesn't matter. Our sender in this case would be the switch. If we go ahead and just call that after it does each one of these, if we just did the true, we're switching to on, so it just turned it on. We'll send out that message saying we just turned on, and I forgot to compile. So it gave me the new parameter instead of the name that it actually is. If you have one of these nodes and actually like read through the text and stuff, it's like, hey, it doesn't know what this thing is, and using some real technical language for it, what you can do is actually just refresh the node to update after you've compiled. and turned on. This is representing whether it just turned on. And yep, we just set it to on. We're going to call that event dispatcher again for the off branch, but pass a false value. File save. All right. So it's now just going to shoot that message out. But dispatchers is basically using a subscription message and listener type setup. The objects that you would want to respond to this have to say, I need to know when this message is sent. They're going to bind a function to it to get notified when that happens. So for that, we need something to respond to this. We do have the cannons, but let's create a new object. Let's call it just like an elevator or moving platform, or however you want to think about it. We'll just be creating another actor that is set up on, of course, focused on the chat when I moved that. We'll call this BP elevator. All right. So our elevator, we're going to, we'll use a timeline for this one, just since Austin had mentioned it. But we will need something for it. We'll just use a simple box or cube, rather. Cube, and scale it to be a little bit flatter. And all right, super small. We'll scale it out a little bit so it's a little bit easier to get on. And our event graph. So you mentioned the timeline. We'll use a timeline to kind of animate this elevator going up and down between 2 points. There's a bunch of different ways we could set this up. We will use a timeline, so let's go ahead and create a timeline to get something animated real quick. There's an add timeline option if we just right click. We'll name our timeline. Move up and down. And this is an interesting node because it has a lot of execs that can basically tell it to do different commands, things like that. The timeline itself is held inside here. If we double click that, right now there's nothing being animated. We have to add our own tracks for what we want. We can even have one set up so that it fires off events at certain times, colors, a float. Let's just use a straight vector track since we're talking about position. And let's call this position or location in Unreal. We'll say at time of 0, we'll add a quick key over here, 0, 0, and zoom way out. We'll go way up to, I don't know, what do you think? 100 would be 1 meter. And then maybe we could just add a multiplier to it. 500. All right, well, let's zoom to fit horizontal and then zoom way past. Zoom out some more, 500. All right. Once we're pretty close to the area, we could always just right click and add a key to the certain curve. We'll say at a time of 1, it will have a value of 500. All right. So I added that first key way down, way at 0, and I'm gonna zoom to fit, try and fit everything back in here. Our length of the timeline goes to 5. We'll just say it goes for 2 seconds. And at 2 seconds, we'll add just another key in here. Add key to all curves. 2 seconds. We'll have it drop back down to 0. And that did not create the timeline that I wanted. Some of them are modifying Y, some of them are modifying Z. Fun. I haven't played with the timeline too much for animating vectors, so bear with me for a moment. Y, we don't need. X, we're not going to be animating. Z, though, I wanted a key that's at 1 for 500. And, oh, geez, this didn't zoom to fit last time. There we go. It is going back down. All right. But our first timeline was our first key got removed, was too close, I guess. Or was on one of these different tracks. That was on the Y track. Get rid of that. I don't care about Y. I only care about Z. Add a key to Z. There we go. 0 starts at 0. All right. Then it goes up to 500. And back at 2 seconds is back down to 0. So it should go up and down, or spit out a position that animates up and down. So let's go ahead and say, while this is updating, we need to move our cube. We're basically going to be changing its relative location. Right now it's got 10 in the value here. Let's set that back to 0. So it starts at 0, and then it'll move up to 500. We'll just be setting it directly from the timeline. So with our cube selected, as our timeline updates, we want to set relative location. This new location, we'll just say straight from our timeline position. There's a few different options. We won't talk about those today. And basically this timeline's here. In here, there is an option to have it auto start playing, or if we want it to loop continuously, things like that. We would want this to just continuously loop. We'll have that always playing. But I don't want autoplay because my switch started off in the off position. I want it to only start playing, and we have an option to plug something in here to tell it when to play, or additionally, timelines, when you add them, will get added to the components heading. Our move up and down timeline, we want to just test this and throw one in the level right now. We'll just put it kind of in front of our switch there to make it easy to see. If we play, nothing happens. Timeline doesn't go. Our switch is all working and stuff, and I don't have a jump in here either. But all right. So if we want that timeline to play that we just set up and see what's going on with it, right at the beginning, we'll test it out and just tell it to play directly. Play. A few different options. Do you want it to play from the beginning of the timeline or just play wherever it was left off? Let's just say play. Start moving, essentially. Wherever you were in the timeline, just continue. So now when we play, you see that timeline up and down. All right, pretty basic elevator there. But I don't want it to just play right off begin play. We just want to test that, make sure that our timeline was set up and moving the proper thing. What I do want is this elevator to know about the switch. It should be alerted when this switch changed. One of the ways we can do this and be able to set that in the level is just add a variable to our elevator for its switch. Switch, and we'll say ref. So it's a reference to a switch. The object type, well, we could make it a basic actor, but we want to know specifically about this actor's event dispatcher. So it will have to know about the BP switch type. So we'll set this variable specifically to a BP switch. Object reference. And we do want to assign this to a specific switch in the scene. So we will make it public and edit it in the level. Then with this variable selected, we see under events, we can actually add an event directly saying when the switch changed. This way it'll receive that message and allow our elevator to respond whenever this switch changes. We have a turned on, or it'll be false when it's turned off. So let's just branch from there. And we'll go ahead and plug this in. If it was just turned on, if that was saying true, we'll just have it start playing. If it was turned off or this was false, we'll just tell it to stop. All right. Now, if we just go ahead and play, we still have one problem. I never told my elevator about which switch to listen to. We could have a bunch of switches in here, and I told it about that switch type. Let's duplicate that a couple of times. We now have 3 switches. It knows that it should be responding to a switch, but we never told it which one in the scene. So we'll set that here. We'll say this one responds to that first one. We'll even duplicate this a couple of times. And this one will pair with that one. The third switch. This one will go for the second switch. All right. Now when we hit these, it goes up and down while that's on. And it turns off when that's switched back off. Could have probably hit it so that it only stays on while I'm in the volume, but right now just enter again to toggle it. It's fine. And we got our individual switches working individually with that. The reason where this communication method comes in handy is similar to interfaces. The actual thing sending out that message, our switch, is just saying, hey, it's on. If we had, let's say, a door or something that needed to play its own animation or do something different, if there was a light, for example, we wouldn't have to recreate our switch and have it know about the specifically light. Our light would just need to know about our switch and respond when it turned on. Let's do that real quick. Let's set up a very simple light. Let's go for an actor. Stupid bar getting in the way. We'll call this BP lamp, BP lamp. We'll go ahead and add a component to it. We'll add a cone. And we'll add another component. We'll add a light. Just a simple point light. I'm going to pull it up above this, and we'll also change the color so we can see it in game. To blue, that'll be fine. And we'll bump up its intensity so it'll really glow and be obvious. Let's say this light, when we'll also have a reference to a switch. Switch ref. BP switch. Let's do this a bit differently rather than just handling the event like this and throwing that event directly on the graph. Let's say when this lamp begins playing, it's going to explicitly get that switch and bind to that certain event. This is basically saying the lamp, when it starts, asks that switch, hey, let me know when you're doing this and I'll have my have an event run for you. So we'll bind to, call it just changed, switch changed. We then can plug in a certain event that we want. We'll just create a custom event for it. Custom event, switch changed on switch. A little bit of a weird name there, but good enough. If the switch was just turned on or off, we'll branch because of that. And quick way to turn this light on or off. We'll grab out that point light, and there is activate. We'll say true. If that's turned on, it will activate, and deactivate if that's false. I haven't used the activate and deactivate too much, so this is a bit of an experiment here. And let's make sure that that's public so we can tell it which switch to respond to. Hop in our level, drop one of these lamps in. We see it is on by default. Let's go ahead and tell it to deactivate when the game begins. So with this, all this stuff is running when the game begins. It is tied to this, basically just telling it what event to call if that switch calls that dispatcher. But anything we connect right up here would be right after the game begins or it spawned into the level. We'll grab our deactivate and see if that'll shut the light off when we begin gameplay. It does not. All right, cool. Access prop, oh, none. So we are getting an error this time. It's saying inside BP lamp in the Uber graph, the event graph, bind event switch. So reading that message again, access none. Well, what did it access none trying to do? Well, switch ref. So switch ref wasn't set to anything. That's basically what that's saying. And all of these hyperlinks can bring you to the exact spot that's happening. Here is where it's trying to access that switch ref. So it failed right here and definitely didn't run the deactivate. And you say you can deactivate the point light in the details panel. Yes, probably. But for right now, we need to fix that and actually let our code run, because it wasn't even getting to this node because it failed this part in the sequence. It won't be able to continue anything on. So always fix your errors before moving on. We need to tell it which switch to respond to. Well, switch 2 is kind of where it's at. So we'll go with that switch. Now with that error fixed, we still see it didn't turn the light off, and it didn't respond back when we aren't getting an error when we stopped playing, but the activate and deactivate is not doing what I was hoping it would. So instead of activate and deactivate, what we'll do is change its visibility. So replace those. Sorry, I just wanted to try that. To me, activating a point light would basically make it visible. But we will just explicitly say set visibility. So at the beginning of the game, sets its visibility to false, so it won't run or won't be visible in game. I'm going to copy that down here for when the switch changes to respond appropriately. And since I'm just basically changing a bool here, I'm given a bool here. Rather than branching and duplicating that code, let's just say, well, if it was turned on, let's plug that in as our new visibility. So when it sends a false, it'll set the visibility to false. And didn't connect that pin up. There we go. All right. File save. Hop back over to Unreal. Press play, and we see it's not visible now. We do have that cone visible. We're just turning the visibility off for the light. When it's on, it's on. When it's off, it is off. And it's not only controlling just the light, it's also still controlling that moving platform as well. So my switch didn't need to change for that one. And in that case, our switch knows nothing about what it's affecting. It just shoots that message out. And if a message or if something subscribed to it or basically bound to one of its events, then it'll react. Okay. So any questions about event dispatchers or any of the stuff we went over today so far? Cool. All right, well, I'm gonna stop the recording here. We'll take a 10-minute break, and then when we get back, we'll talk about the Unity's or Unreal's navigation system.